Yeah, good to go.
All right. So yeah, once again, welcome everyone to this session. So what we will be discussing today is basically AWS service called as Route 53, and then we'll understand how it works, all the different flavors of Route 53, as well as towards the end, what we'll try to do is we'll try to see a few scenarios where we can involve or where we can use the AWS Route 53 along with MuleSoft in the various architecture or design diagrams that we can think of, or of different use cases that we might have in our client engagements. So what we're gonna have in this session is to start with, we'll have a bit of understanding of the DNS because that's the root of the AWS Route 53 service. So we'll just go through a bit about the DNS and how it works and all the different kind of components that are involved in the entire DNS ecosystem. Once we do that, we'll move towards specific service, which is the AWS Route 53 service and all the different flavors that it provides. Once that is done, we'll try to shift our focus to the MuleSoft side of things. And in the end, we'll have a demo where we can try to make use of all the things that we've gone through the session and have something up and running. Okay. And then in the end, we'll have, I think, a question and answer as well as a quiz for everyone, right, Ashish?
Yes, Vibhav. Yeah.
All right. All right. So let's start with this session now, the AWS Route 53 with MuleSoft. And as I mentioned, before we go into any further details, we need a kind of refresher for the DNS or the domain name system. So this is something that we all have been using quite a lot. We know what it is, but it would make sense just to have a kind of a refresher so that everyone is on the same page, especially when we go to the later slides. Okay. So DNS essentially, I mean, if you see the slide, it's just like a phone book. It acts as like a phone book for the internet. So let's say we want to access any particular server or any particular website or any other system on a network, whether it is a private network or even if it is like a public network like an internet. As you are aware, probably that all the systems only communicate with each other with the IP addresses. Now, we as humans have a tendency not to memorize all these IP addresses that well and keep them all in mind. So, let's say if you have a shopping site, we know the name of the shopping site, but we don't recollect the IP address of it. So that's where the analogy comes from the phone book. We know that we have to call a person, but we don't know the number of that person. So based on the phone book principle, the DNS entire system was modeled. So what happens is, in a simple terms, we put in a domain name such as Amazon.com as an input to the DNS system, and the DNS systems sends back the corresponding IP address for that particular domain, which is in this case, for example, Amazon.com. Okay. So the benefit that it has is, I think, quite obvious that we don't have to remember all those lengthy numbers, especially the number that you see on the screen right now. This is like a IP version 4 address, which is still somewhat manageable. But with the new set of IP6 addresses, the IP version 6 addresses, it becomes even more difficult. So that's the place where DNS comes in handy. Okay, so we know now what DNS is, that it takes a domain name as an input, whether it is Amazon.com, Yahoo.com, and then it goes and returns back the corresponding IP address. But it's not as simple as it sounds. So there's a lot of systems or subsystems in the DNS entire domain name system that act together or orchestrate things by which after they complete their tasks, respective tasks, we get the final IP address of our destination. So to better understand how this entirely works, we can have a look at this diagram. I hope the diagram is clear, or I'll open a different version or a different image of this where I can zoom in. Can everyone read these things that are mentioned over here? Is it readable
Yes,
for you?
yes, Vaibhav. So
All right,
I can.
perfect, thanks. Okay, so let's take a typical use case. We as a user, we go to a system, let's say this is a laptop and it's having a Chrome browser installed on it, and we need to access the Amazon web page or the Amazon website. Now, we do not know the IP address of Amazon.com. So what do? We just enter in Amazon.com in the browser of our system. and then we hope something magic to happen behind the scenes by which their Amazon.com web page will load. But how does the magic happen is the question. So in typical scenarios, what happens is Amazon.com in your browser or on your system, there's we can enter it in multiple places. So for this use case, let's consider the way entering it in a Chrome browser. So the Chrome browser itself might have some kind of a local caching in place. It might have something cached for Amazon.com that okay, Amazon.com is resolved to this particular IP address. If it finds that caching in place, it's just going to return that IP address back and can do the rest of the communication directly with the server. But to start with, let's assume that there is no caching in place in this entire infrastructure right now. Okay, so it's a fresh request, Amazon.com. Google Chrome browser does not know how and where to find this Amazon.com. So what it does is the next step, it forwards that request to something called as a DNS Recursive Resolver. Now, DNS Recursive Resolver is one of the key components of the entire DNS system. It is also called as a just as a recursive resolver, maybe a DNS recursive resolver or just a recursive resolver. Now, typically, this is a part of your ISP. So, whichever ISP you're connected to, whether it is, let's say, Tata Sky or Airtel or any other ISP that you're connected to, they have this component running on their servers, which is called as this recursive resolver. The primary responsibility of this recursive resolver is to take in requests from the clients, or you can say from the users, and then through a set of orchestration, send back the actual IP address back to the calling client. So in this case, what is happening is we sent Amazon.com to the Chrome browser. Chrome browser is forwarding it to the DNS recursive resolver. DNS recursive resolver, okay, it sees that okay, it is Amazon.com. What do I do with that address? What it does is it sends it directly to something called as a root server, which is this part. Now, the root server is something like the apex of the entire DNS system or the entire DNS structure. It's like a set of 13 set of root servers. You can see they are strategically located around the world. Okay, so when I say 13 set, it's not just 13 servers; it's 13 sets of servers, which are together called as root servers. And these root servers are not privately operated. They are operated by different organizations around the world, but they are not privately operated. Okay, that's another thing. It's like non-profit organizations that normally look into the administration and entire working of these root servers. So they act as the root or the apex of the entire structure. So when the root server gets a request from the DNS recursive resolver, what it does is, okay, it thinks that, okay, I don't know what Amazon.com is, but I do have a reference to the .com TLD server. So this is one of the feature of root server. It has references to all the TLD servers. TLD servers are in short called as top level directory or top level domain servers. So anything after the final dot that you see, whether it is Amazon.com or let's say if it is Amazon.co.in, then .in is the TLD server or the TLD context over here. So what the root server says is that okay, I don't know what you're talking about Amazon.com, but .com TLD server is something mapping that I have. So what I will send you is the IP address for the .com TLD server. So that is what it returns back. If you see the line over here, line 4, the step 4 over here, the IP address of the TLD server is returned back to the recursive resolver. The next step over here is that recursive resolver sends the same request to the newly obtained IP address of the TLD server. Now the TLD server checks its settings and its all its directories and all, and what it finds is that okay, I know where Amazon.com is hosted. So the TLD server will be just for things such as .com, .net, and all those things as I discussed. It does not have any information about Amazon.com in particular. But what it does know is that I know that there'll be a name server. So this is the last component over here. That name server will have all the details such as IP address for Amazon.com. So what it will do is it will send back the IP address of the authoritative name server. Authoritative name server is the final server in the entire hierarchy which has the actual IP addresses mapped to the domain name. Okay. So when the TLD server sends back the IP address, it is the IP address of the authoritative name server. So the recursive resolver gets that and forwards the request again now to the authoritative server. Okay, so this is where all our mappings, all our domain DNS records, and everything reside for Amazon.com. So once this particular server gets a request for Amazon.com, it checks its internal directories and finds a matching entry over there. Okay, Amazon.com, I have all the records for it. I know that Amazon.com maps to this particular IP address, and it sends back that particular IP address back to the recursive resolver. Okay, so the thing to note over here is the authoritative name server will have all the IP addresses mapping for all the records. So let's say whether it is Amazon.com or for all these subdomains or also for Amazon.com. So let's say if it is shopping.amazon.com or deals.amazon.com, so all those records will be present in this authoritative name server. Okay. So what this server does is sends back directly the corresponding IP address, which is step number 8. The recursive resolver gets that, it sends it back to the calling user, which is this laptop or the Chrome browser. What the Chrome browser or the laptop does, it just takes it and then sends it to the actual Amazon web. And then the corresponding web page at that particular location is sent back to the user. So this is what all happens behind the scene when you type in a request for Amazon.com and when you get back the web page. Now you must be wondering whether all these steps keep on happening every time. Then the answer is no, because there's different levels of caching everywhere. So there's caching at the browser level, or you can say the system OS level. Also, most importantly, at the DNS recursive resolver level itself. So let's say if the next time the user sends a request for Amazon.com, the recursive resolver, based on a certain TTL, it might or it might not have an entry for this particular request. If it has an entry in its local cache, then it will not go through all these steps of going to the root server, to the TLD server, and the authoritative name server. It will directly send back the corresponding IP address back to the user, and then the user is redirected to the web server. Okay, so that's where caching and TTL comes into picture. But otherwise, these are all the components. These are all the different kinds of servers that are involved in this entire orchestration. Let's move on to the next slide. Okay. So if I just go back again, we talked about the authoritative name servers, right? And I mentioned that if you see over here, there are all different kind of DNS records for the domain are present in the server. So that actually brings us to the next topic, which is the different kind of DNS records. Okay. So I've just mentioned a few.
Fiber, sorry
Uh,
to interrupt.
yes, sir.
There is a question from Sonic. Where is the third party DNS recursive resolver hosted?
Yeah. So typically, this DNS recursive resolver is a part of your ISP. So you're connected to your internet provider, right? So that internet provider, which is the ISP, the internet service provider, has a DNS recursive resolver. Okay, so by default we connect to that and we make use of the DNS recursive resolver provided by our ISP. But there are public recursive resolvers also which are available, and if needed, we can configure our system to use those public resolvers rather than using the out of the box or the default ISP recursive resolvers. So that is also a possibility, but normally we go for the ISP's recursive resolver itself. Does that answer the question?
Yeah, yes, thanks.
Thank you. Yeah. Okay. So these are some of the common record types that are stored into this authoritative name server. Okay. So the first one is called as a record. So A record is a simple record in the DNS system which returns basically a IP version 4 address. Okay. We'll go into more detail on this, but the basic is it just returns a single IP version 4 address, and that's the critical part over here, that A records only return IP version 4 addresses. Okay. So it's like you send in a amazon.com domain name and it will return 120.33.44.120. So that is like a IP version 4 address returned by an A record. Now AAAA record or 4A records is basically the same thing like a record, but the only difference is that we use this record for a version 6 address. So again, you can get an amazon.com domain name, But if it has IP version 6 address, then that will be basically stored as a AAA record. Now, the third one, and which is mostly of most importance to all of us, is a CNAME record. A CNAME record is also called as a canonical name record, which basically maps one domain, okay, or a subdomain to another domain. So the key part over here is that all CNAME records must point to a domain and never to an IP address. So the difference, if you see in A record, AA, and CNAME record, is that A and AAAA records point to an actual IP version 4 or version 6 address, whereas a CNAME record does not point directly to an IP address. It has to always point to some other domain name or a subdomain. So what that would mean is that, one second, let me try to bring up one notepad or something. Can you see my notepad, or can you just see the slides?
Only slides.
Okay, let me see how I can bring this to different. Hold on.
You stop and share the whole screen so we can.
Okay, one
I
second.
think you are only give out permission to share only this slide, I guess.
One second, let me try doing it.
Yeah, okay.
I selected entire screen, but it's able to select only one or the other screen.
Okay.
Anyways, let's proceed. I'll just come back to this. What I was trying to say was that if we consider the same case, such as Amazon.com, then for a CNAME record, which is over here, okay, the CNAME record in Amazon.com, let's take an example, a better example of shopping.amazon.com. Okay, so we can have a record called as shopping.amazon.com, but it will not point to an IP address. Maybe it is going to point to Amazon.com, and then Amazon.com will have an actual IP A record, which will point to the IP address. So don't worry about it right now. We'll have some more slides later on and some demos in which all these things will be clear. And just to cover up the last two one, the NS, or the name server record, this is basically where the internet knows where to find the records. So where the IA record is, where the AAA record is, and the CNAME record is. So all those things it can find basically using the NS record. Again, we'll come to this when we do the demo session. The last one is more for housekeeping purpose, the SOA record, which is the start of authority. It stores the information about the admin, such as the domain, the email address of the administrator, and all. Okay, so I think the most important one for us are the first three, or in fact, I would say the A record and the CNAME record. Okay. Okay, so now since you have a basic understanding of what DNS is, how it works, then I think it's a good time to start with the AWS Route 53 service. Okay, so this is basically a service which is global in nature, provided by AWS. So when I say global in nature, it is not tied to any particular region. So if you guys might have worked on AWS or any other cloud computing system, normally they have services which are bound to certain regions, such as, let's say, Asia Pacific or US region and all. Whereas there are certain services which are global in nature. So this is one of those global services which is not tied to any particular region in AWS. Okay. It is highly available, reliable, as well as a scalable domain name system provided by AWS, and it basically does three main things. So the first thing, if you see, is domain name registration. So it provides a set of screens wherein we can go and buy and register a domain for ourselves or for our website or for our server. So let's say if I want a domain called as vaibhavkatkar.com, then I can go to AWS Route 53. They will provide an interface for me to check if that particular domain is available. They'll show the pricing if it is available, and I can buy it there itself. So it is similar to something like what GoDaddy does or some other domain name registrars are, but it is one of the feature functionality provided by Route 53. Second is DNS resolution. So this is the core capability provided by AWS Route 53. And it provides features for hosting records. So the records are what we have just discussed for a given domain. So if I have my own domain, I can have all the records hosted over here. And the third one, which is also a critical thing, is health checks. So health checks is like something that can be configured for all the resources that you have deployed, whether it is in let's say in your AWS system or anything outside the AWS. You can configure HTTP health checks basically to see if your resources are up and running. And then based on these health checks, you can do different activities or different solutions basically for the DNS resolution. So it will be covered as a part of our demo, how health checks can be used for DNS resolution. Okay. Now, these are the different routing policies that AWS offers. And before we go into what these routing policies are, we need to understand what exactly routing policies do. So routing policies is basically, if you remember, if I enter a domain name Amazon.com, you know that the DNS system will return me an IP address. Okay. What these routing policies do is add some flavor to it based on which we can select if we need to send the same IP address or some different IP address. So there are different flavors of these routing policies based on which we can get different answers for the IP address returned. And we'll go through them as well as some of them will pick up for the demo so that will be more clear regarding what it does. Okay. So just to give a brief idea about them, simple routing is the most straightforward routing. It will just route traffic to a single resource. Multi-value answer routing is like, let's say if I give Amazon.com as a query, then the DNS will send me up to 8 healthy records. So when I say 8 healthy records, it's basically 8 IP addresses that the query will send back to me. And now that 8 healthy records depend based on if all the 8 are healthy based on the health checks for the AWS that we just saw. And then what we can do as a client or as a user, we can select one of those healthy IP address and send back the request to the actual site. The third one is weighted routing. So weighted routing is basically to route traffic based on the weight associated to each records. So we can have, let's say, dev.amazon.com, and dev.amazon.com might point to two servers, and we can assign some weight to it. Okay, 10% to server A and 90% to server B, so that the traffic will go 10% to the server A and 90% to server B. We'll go in more detail in all this, but it's just like a one layer introduction I wanted to do for all of them. The failover routing is again for a active passive failover mechanism. So we can have the same functionality deployed on two servers. One will be in active and the other will be in passive mode. If in case the active server goes down, the routing or the AWS Route 53 will forward the request to the passive server. Geolocation, geoproximity, and latency. These are three things, all based on basically the location of the users and where the resources of the server is. And I think rather than here, we'll go into the next slides to discuss more in detail. So we'll start with simple routing first. This is something what a simple routing does. It is used to configure routing for a single resource. So basically, you cannot have multiple records that have the same name. So if you see this example over here, okay, this is the name, okay, this is a record. I can have multiple values with it, but I cannot have another name, another record, basically www.example.com, with basically a value to it and the routing policy as simple routing. Okay. The other critical thing is that we cannot associate health checks to a simple routing policy. And the last and the most important thing is the TTL. This is the time to live. So this is basically in seconds and how much time these records will get cached at different layers, such as the recursive resolver or at the browser level. Now, if you see multi-value answer routing with simple routing, the difference I think is right over here in this example. We have the same name, www.example.com. It is again type A record. The values are different now. Okay. So what happens is that if a user enters www.example.com, okay, the user will get all of these three records. So the person will get, or the system will get all three IP addresses. Then they can select one of these IP address and send it back. send a request to it. Now it depends whether all three are healthy. And when I say healthy, it's based on this health check, the last column over here. So if they are healthy, then all three will be sent back up to possibly 8 records. If any of them is not healthy, then it will not be sent back in the response. Okay. So the third one, and probably one of the most interesting one, is the weighted routing. So I think straight away we can see this table over here. I have 2 records with the same name, weighted.vaibhavvatkar.co.in, and the second one is also having the same name. Both are C names. When I say C names, if you see, what I'm doing is I'm mapping it to another subdomain. Okay, so this particular first record, weighted.vaibhavvatkar.co.in, I am mapping to, this is a load balancer. I'll come to that in the demo session. But for now, let's consider this is a load balancer, a MuleSoft dedicated load balancer. Okay, and the second one is basically another load balancer. So SG over here is Singapore. So this is in Singapore, and US over here is a US. Both are MuleSoft DLPs that I've configured. And I've configured 2 records over here. The first record is CNAME mapped to this, the Singapore load balancer, and the second one, which is having the same name. So this is the critical part, okay? The record name is same. It is pointing to the US load balancer. Now, what do I want to do with these mappings? What I'm trying to do over here is associating different weights to both these records. So for the first, I assigned a weight 30, okay? And for the second record, I have assigned a weight 70. So if you add this and calculate the percentage, this record is going to get 30% of the traffic, and the second record is going to get 70% of the traffic. In short, if I query weighted.vaibhavvatkar.co.in through any system across the world, out of 100, 30 requests will go to the Singapore load balancer, and 70 requests will go to the US load balancer. And this is completely configurable. You can change this value from 30 to 40, 50, 5, 10, 80, 90, anything. Okay. So where do we use this? And obviously we'll come to this in the demo part also, but I've just mentioned it over here. It's normally used for Canary deployment models. So what I mean by Canary deployment model is basically, let's say we have version 1 of any API deployed, let's say on a server. Okay, let's say version 1 of API deployed on one server, which is there in production, and resources are using it. Or let's say instead of API, I can just take version 1 of a particular shopping website, okay, that is there in production and people are using it. Now your CTO or some from your tech team or higher management wants you to release certain new features, okay, to the end users. So what you'll do is you'll create a new version 2 of, let's say, the API or the website, and you'll deploy it to production. But what you have been told is consider that only certain amount of traffic should go to the new version. So let's consider this record is the new version, so that we can do kind of a feedback. We can gather a bit of feedback of what the users feel of the new, whether it is the API or whether it is new website. So if you just limit this new website to, let's say, 5% of the traffic. So let's say if I have 5 over here and 95 over here, then only 5% of the traffic will go and access the new functionality. They will be able to give me feedback about, okay, what seems cool, what is not that great. And then based on that, gradually what the management can do is increase traffic. If everything looks fine, they can increase the traffic for the new one. So from 5, they can increase it to 50, then gradually to 75. And then finally, they can have it as 100. And this one, they can have it as 0. So what we are essentially doing is that all the traffic that was initially going to version 1, now we are shifting gradually just by simple configuration at the Route 53 level, nothing in the code. You are shifting it to the second one, which is the version 2 of the API. So this is one of the use case of a weighted routing policy. Let's go to the next one. Oh, sorry, one thing I have to mention is the differentiator that you see over here, right? So this does not need to add up to 100. For this example, I've taken it to add up to 100 just to show that it 30% goes over here and 70% goes over here. But the idea is that you can assign any number between 0 and 255. So let's say if you assign around, I would say 124 or something over here, and the other is also having 124, then what it does is it adds both of them, and then it takes a percentage of the total value. So it will be around 50% for the first and the 50% for the second. Or let's say if you have another record over here, weighted.vaibhavatka.co.in, and I put the weight over there to 30. Let's say if I have 30, 30, and 40. Okay, then it will add up, and then based on it, it will find some values, find the actual percentage value. So you're not restricted to 0 to 100, you are restricted to 0 to 255. For the same record, it will add up everything and then calculate the percentage. So we don't need to calculate the percentage. AWS Route 53 does it automatically.
Vaibhav,
Yeah, sorry.
yeah, in this use case, right, where we are publishing the version 2 of your website. So the website URL will be same, right? We are
Yes,
not going to
yes.
change that URL. The
Yeah,
record
so the
like
URL
how,
will be this.
but then how you will differentiate that this is the new one and that is
No, the idea is that the users are completely transparent to it, right? So we
correct,
don't
correct,
want a user to know which site they are referring to. Okay,
correct.
so out of 100 users, randomly what we want is the intention is that only 5% of the users should go to the new website. We are not going to select 5% of the users. Randomly, it should go 5% to this website and the rest 95% to the old website. So
Yeah,
it's
yeah,
just a segregation of the traffic. It's not segregation of the users.
yeah. I got your point. The last column will be playing big role here, right? Not the first column.
Correct. Yeah.
Am I
Actually,
clear?
the first column will remain the same because this will be the
Yeah.
access point for the users. The end users will all, if you see this name, the record
Mhm.
name is same for all the records.
Correct,
And it
correct,
has to be same for all the records. Because if that changes, then it does not make any sense, right? Because then
correct,
it is a
correct.
completely different end service itself, or you can say different API or a different website itself. So that
Correct,
does
correct.
not make that will not make much relevance then. So this has to remain the same. If we
Yeah.
have this record name across all the records for that particular routing strategy or routing policy, then only it will reach AWS Route 53. AWS Route 53 will see, okay, I have two records for that particular record name. Okay, what I will do, I mean, what AWS Route 53 will do is will ensure that the number of records it gets, 30% or 5%, whatever is defined over here, it will send to this particular, in our case, this is a load balancer, but it can be anything, whatever end resource that you want over here. It will forward it to this host name over here, or the rest of the traffic will send to this.
Okay. Okay. The last column will have the actual URL of V2. V2
Yes,
or
yes. So
the load
correct.
balancer where the
Yes. So this is
that.
V1. This should be
Mm.
the V1. In our case, I would just put the DLB for V1, you can say, and this is for DLB for V2. So these are different hosts, okay, different load balancers I've put over here. Okay.
Yeah. But
These are, if it is in the
Vaibhav,
same host, then we cannot do it then.
yeah, yeah. So in the
Because
real
here we
scenario,
cannot.
right? In the production scenario, you'll be having single load balancer, right? So if, let's say you're hosting some, let's take the example of MuleSoft applications,
Yeah,
right? So
correct.
you'll be deploying behind one DLP, right?
Correct.
So there you mean you need to create separate DLP to differentiate or
Yeah,
split between the new services.
that is correct. If it is the same DLP, then this will not work over here. So this is mostly, let's say, if you have in different regions, or if you have two DLPs which are serving the traffic, different load balances serving the traffic and all. In that
The way,
scenario itself.
yeah, the way we do for our external traffic and internal traffic right now in our architectures, right?
Correct.
Okay, yeah, thanks.
Any other questions that we have so far? Or can I proceed?
Yeah, we are good so far.
Okay. So another important one is failure routing. Here, it is in fact quite an important one. What we do is we have a concept of a primary resource and a secondary resource. Now, again, when I say a resource, consider it as anything. It can be a MuleSoft API, it can be a website, or anything. The idea is that whatever is deployed on the primary resource, exactly the same copy is deployed on the secondary resource. Okay, so both the servers should have the same copy of whatever is deployed. So for this use case, let's consider there is a MuleSoft API deployed over here, and we also have the same MuleSoft API deployed over here. Now there's AWS Route 53 in between, and the user is trying to access basically the API. the user obviously is completely transparent to which server the request is going to go. How we have configured this entire landscape is that this particular server will always respond to all the requests. Okay, and this server is in passive mode. What happens is, when I mean by passive mode, is that only when this server goes down, the primary server goes down, this kicks into action and will start servicing the request. So for this fail, called as basically failure, that once the primary is down, the secondary takes over and services the request. So for implementing this failure, we have something called as a failure routing policy in AWS Route 53. What we do is we have a primary resource defined, secondary resource defined, and then the important thing is we associate health check with the primary resource. So what health check does is ensures that this primary resource, or let's say our API, is up and running. So health check is something like behind the scene in the background, certain pings or certain HTTP requests that Route 53 will send across to the Mule app, and the Mule app will return to it, let's say with 200 OK or something, so that the AWS Route 53 will understand, okay, this server is up and running, so I can keep forwarding requests to the primary resource. Let's say if the health check starts failing, so instead of this green tick mark, you get a red over there, red cross over there. So by that, what Route 53 will understand is there's something problematic with the primary resource. It is not reachable. It is sending me back error responses. In that scenario, the failure will be implemented. So what this will do is automatically send a request that it receives from the client to the secondary resource. And the secondary resource will send back the responses. So this will go on, keep on going on until and unless the health check detects that this server is again up and running. So as soon as this server is up and running, automatically the request will again get forwarded to primary resource, and this will again go into passive mode. Okay. So this is one of the use cases that we can think of as we have two regions. Let's say if we have deployed APIs in two different regions, and one is just acting as a backup region or a passive region, okay, and we're redirecting it to a main primary region. But let's say if the entire region is down, then what we can do is we can just send it to the APIs deployed into a different region, and that region should hopefully be up. I think as far as I know, the region has never gone down entirely in AWS, but just a scenario, if we want it to be handled at the application level, we can have something like this. Okay.
Sorry to interrupt. There is a question.
Yes, yeah,
Can
sure,
we apply weight and routing between CloudHub DLB and AWS ALB?
can we apply weighted routing between
CloudHub
DLB?
DLB and the AWS ALB.
Correct. I mean, ALB, you mean to say the application load balancer provided by AWS, right?
In case of RTF on EKS.
Okay, so in that case, I think what you're saying is that here will be the ALB's host name, right? If I'm correct. We can do that. The only idea is that if you want to pass it to an ALB's, AWS ALB's ALB, the rest of the services that connect to the ALB. Is that?
Yeah, he's saying is correct.
Perfect. Yeah. As long as you have a host name over here or domain name over here, you can forward the request to that particular server, and then it's the responsibility of that particular server to forward the request to. I mean, basically, it's let's say if it's a load balancer, it will act as a reverse proxy, right? So it will send it to all the clients who are subscribed to that load balancer. So that should work then.
And one more question from Reena. How does AWS calculate the split of request for weighted routing? If it is 70 to 30, does it split for simultaneous request?
So as I mentioned, you can mention any number over here for the differentiator. Okay. So if I spend, let's say if I have first record as 120 and second record, I've just mentioned the number as 30. Okay, so what AWS does is it will add 120 and 30, so 150. So this record is having total value as 150, and then it will calculate percentage for first record as 120 divided by 150 into 100, and for second it will calculate it as 30 divided by 150 into 100. Is that clear?
Yes. So it will be again, per minute calculation or something like that.
No, overall traffic. There is nothing mentioned like, okay, for 1 minute it is going to send. It is based on total number of requests that you get, not for a particular time unit as mentioned for this policy. So let's say if you
Okay.
send 100 requests, it will not maintain. I mean, internally it might be maintaining somehow, but at least that is not visible when we configure the policy. The only details that are visible are what record name you want, where the users will access, and how you want to split the record, and where you want to route the traffic to. Time interval is something that is not mentioned anywhere.
Okay. And background, we are not sure how it splits.
You mean time interval, right?
Yeah. So in my case, in a day, I might get 1,000 requests in a minute.
Okay.
Or even more than 1,000 requests,
Right.
10,000 requests in an hour.
Correct.
So how does it differentiate? How does it calculate? Okay, I'm gonna get 10,000 in this hour, and I'll split it as 30, 50. Sorry, 30, 70, or
Correct.
when even 40, 60. How does it calculate? How does it anticipate and do the splitting?
Correct. So what it does have is just the percentage that it has to send to. Okay. The exact algorithm they have not published openly. I have at least haven't seen anywhere. But then behind the scenes, it does calculate that. Okay, if I get a new, send it to this record or this record. That is something that is not shared. At least I am not aware of. I can check and get if there's anything, but as of now, I'm not sure if there's anything.
Oh, okay. Thank you for answering the question.
No problem. Should we go ahead, or is there any other question?
Yeah, Koji, you can go ahead.
Okay. So this is Failover. I think we completed this. We'll quickly go to the next one in the interest of time. Okay, so geolocation is basically if I, as a user, want to access a server and I want specific contents for my geography. So this is something we all of us might have always experienced. That let's say we try to access certain sites and we face some restriction that okay, this site is not accessible in this country, or that site is not accessible in another country. So how do we implement that kind of functionality? It is based on something called as geolocation routing. So in geolocation routing, what we can do is basically set up records based on the geography of the calling user. So let's take this table again. I think we're using the table, right? So it will be easier to understand. I have again the same record name. This time I've named it as geolocation.vaibhav.co.in. Okay, the name is exactly the same. Type is Cname. Why is it Cname? Because I am again pointing to a domain name. So again, this is the Singapore load balancer. This is the US load balancer. Okay. Now the routing policy is changed. So I've used a geolocation routing policy. Now the differentiator is something different. Okay. In the weighted routing, we had a differentiator as 30, 70, and all those numbers. Here we are having differentiator as Asia and United States. So this is just an example. This can be anything. It can be countries, it can be continents, but I think in the case of US, it can be at the state level too. So what does this table tell us now? If I go to my browser and type geolocation.vaibhav.co.in, okay, if I am accessing it from Asia, it will always go to the Singapore load balancer. So maybe I've configured this considering that, okay, all Asia users for them, the nearest load balancer will be ST load balancer, Singapore load balancer. So I want them to redirect over there. Whereas if someone accesses the same API or website and that user is in US, then what I want is that the user should redirect to a US load balancer. Behind the scene, they might have the same app, they might have a different app, anything that is completely up to our implementation. But this redirection is what I want based on the geolocation of the user. We can add another record over here with the same name, geolocation.vaibhav.co.in, everything same. And the differentiator will be something like default. So if the incoming user region does not belong to Asia, does not belong to United States, then basically it will go to the default record and it will basically route to whatever value we mention over here. Okay. So this is how this geolocation works. It's based entirely on the location of the calling user, the calling user's IP address, you can say precisely. Now, geoproximity is something similar to geolocation. There is just a slight difference over here. Let's go to it. So here basically we are routing based on geoproximity of users and resources. So when I say users, it's called the client application or the calling application. Resources are your servers or your APIs or anything. Okay. The added flavor with geoproximity routing is that we can assign a bias value. Okay. We'll come to this, what the bias value is. Why do we use this? Is basically when we want to route the traffic on the location of your resources, and more importantly, optionally shift the traffic from resources in one location to another location. So the question is, how is this different from geolocation, right? In geolocation, if I go back, once we define it over here, if I'm calling from India, it will always go to the Asia differentiator and it will always go to the Singapore load balancer. Okay, but let's say for certain reason, for certain time, I want to be redirected, even though I'm from India, I want to be redirected to the US load balancer. Then it becomes difficult to configure that over here because you'll have to make some additional entries over here and all. So rather than that, what we can do is we can have a geo proximity routing in which then we'll come to the bias value. The bias by default is 0. Okay, so when I say bias is 0, and let's say if you see this diagram, I have one server in India. Let's say this is in Mumbai over here, and the other one is in UK. Now, if I have a bias as 0, everything in blue that you see, anyone calling from the blue region will be redirected automatically to this server. And everyone calling from the red region that you see in this diagram will be redirected to the server in UK, which is number 2 over here. Now, the point is, this is for bias is 0. When I say bias is 0, that means I'm just splitting the traffic evenly. But now, let's say if I keep on changing the bias value, let's say I have a bias 60 for the first resource, okay? So when I say bias 60 for the first resource, I mean this first server, I'm saying that I want, this is the default traffic, I want more 60% of the traffic to be redirected to this region, to the first server. So if you see now, the region has now increased. So this entire blue region now is going to go to this server, whereas only the remaining, this circle that you see red is going to go to 2. And how did we change this? By changing the value of the bias when we set the records. Okay. The next one is latency routing. Now, again, this is slightly similar to the previous two. What we do over here is, this is the user, if you can see. User can be yourself, anyone trying to access our APIs. Okay. We have the APIs deployed in different AWS region. Okay. What we do is, I mean, when we say what we do is, AWS Route 53 is, it calculates the latency from the calling user to the AWS region where it is deployed, the API. So Route 53 calculates that, okay, for a user calling from this region, if he has to be sent to UK region where their server is or the API is, the latency is, let's say, 30 milliseconds. Whereas if we have to redirect the person to the US East region, then the latency is 200 milliseconds. So in this case, AWS Route 53 selects the path with the lowest latency and sends the request to that particular server. Okay. Now the only constraint over here is that it should be, in this case, it should be associated with AWS region. So this particular server or this particular server, we need to associate it with in AWS region. Then only we can set up this latency routing. Okay, so now we know all the different policies of AWS Route 53 and we have a fair idea of how it works and all. What we'll do is we'll try to understand how we can fit in MuleSoft or where we can use all these policies along with AWS Route 53. And the first and most important one, I think quite a few of you might have already used is we need something called as a MuleSoft DLB vanity domain mapping. So for dedicated load balancers, normally we get an IP address, a domain name in the form of this. Okay, so it will be whatever name you give for your DLB name, .lb.anypointdns.net. Okay, and as you know, this is not a URL that your client wants to use, right? Because most customers typically want their clients to access using their own DNS. So let's say if you create a DLB, it has this particular DNS name, DNS record, but your client wants to access it from their own company's site. Let's say the client is, let's say for example, Telhio or something like that. Then they want telhio.com and then whatever the path is for the resource. So what we have to do is we have to map the client's vanity domain name with this particular DLB's domain name. And the way we do it, I think by now you must have guessed it, is we have to create a Cname record, okay, which will map the vanity domain name. Okay, so let's say the client is vaibhavbhatkar.co.in. This is the website. I mean, just an example. This can be Amazon.com or anything like that. Okay, so what I can do is I can have SG standing for Singapore subdomain, singapore.vaibhavbhatkar.co.in, and then it will map to the MuleSoft anypoint DLB SG-DLB lb.anypointdns.net. So the simplest thing that we have to do in this case is go to Route 53 and enter this record that you see on the screen over here. The record name, okay, sg.vaibhavbhatkar.co.in. So this will be what the users want to access. Okay, so here is the vanity domain name. So let's say if your client is alliance.com, then it will be like dev.alliance.com or uat.alliance.com. All those things you can mention over here, whatever you want the vanity domain name to be. Have the type as CNAME. And what you can do is, at this stage, you can just have a simple routing policy, and the value will be the load balancer, the dedicated load balancer domain name. Okay, so we'll do this in the demo also, but I just wanted to show it over here. And then the second use case is basically we can do load distribution for a MuleSoft API. So a MuleSoft APIs can get a lot of load, right? And we're always looking out for how we can distribute the load across different APIs, especially let's say when they're in different regions. So typically we don't deploy APIs to different regions, but if in case there is a client who wants to have the APIs in different regions for different for the users which are scattered across the world, then all these routing policies will be quite effective. So if that is the case where the APIs are deployed to multiple regions, then we can benefit from them. Such as if we use a weighted routing, then we can associate weight, and then it can be sent to the each and every MuleSoft API. Geolocation, geoproximity, latency, all the things that we just discussed right now, right? So the same thing, and we can ensure that we make use of all these policies at the AWS Route 53 level to ensure that the load gets distributed, as well as provided a better experience. So something like latency and all, if we use, the users will automatically be redirected to the nearest API rather than traveling across the world and going to a server which is located quite far away, right? So all these things will be helpful in those scenarios. And finally, the failure scenario again. This is again what we discussed, that okay, we can have the MuleSoft APIs follow the active-passive failure model. One of the API will act as the primary API and serve all the traffic, and the other API probably in another region will act as a secondary. So this is like a disaster recovery also you can have. So if the region goes down, there's a disaster, then the other region is still up and it can service the request. You have the health checks associated with it. When the region goes down, automatically a failure is flooded and the request will go to the secondary server or the secondary API. Okay. Any questions so far, or you can then start into the demo part?
We are good. Oh, okay, yes. Sorry, there is a question from Sanik. Shouldn't we have a default value for geolocation routing policy? What happens in case we have users from regions that doesn't appear on the geolocation?
Correct. I think that's what I mentioned. It we can have a default record, and any users which are not from that record, basically, any users which are not from the records that we have mentioned for geolocation will be basically fetched from the default record. Okay. So right now, if we let's say if we just have Asia and I think US we had, right, and if someone calls from Europe, then I think I'm almost 99% sure that that request will not get serviced until and unless we have a default record entered over there. So if the default record is entered, we can have it serviced by pointing it to some other domain. Okay.
Yeah.
Okay, I think my screen sharing has stopped. Let me try again. Can you see my screen?
Yes.
Okay, give me a second. Okay, so for the demo, what we'll do is we'll need to have some kind of setup. I hope you can see my screen. So we'll have two different side of setups. One is the MuleSoft side and the AWS side. Okay, so the first thing is the MuleSoft side. Are you guys able to read what is written over here, the text over here?
Yeah.
Okay, perfect. Okay, so the setup that we're going to have is basically, let me go through it. We have a region over here, an AWS region, which is US East Ohio. Okay, in that region, we have one VPC, which is VPC1. That VPC1 has a dedicated load balancer. This is the dedicated load balancer's domain name, us-dlb.lb anypointdns.net. And inside that, we have a simple Mule application, which is having this thing. This Mule application has two endpoints, /welcome/health. Okay. Now what we have done is we have replicated this entire structure in another region, which is Asia Pacific or the Singapore region. Okay. So here we have a VPC called as VPC2. There's a different DLB over here, which is SG. So the way I've differentiated is this is US and this is SG, dlb.lb anypointdns.net. And it is having this application. Now the applications are the same, okay? Exactly the same. The name is different, but the application is exactly the same, /welcome and /health. And then what we're going to do is we're going to connect both these DLBs through AWS Route 53. Okay, so this is all the setup at the MuleSoft side. Let's go ahead. Now at the Route 53, there's a few things that we can do. In fact, what we have to do, one is domain name registration. Then let's say if you're managing a non-AWS Route 53, if you're managing a domain which is not registered with AWS Route 53. So let's say if I have a domain with godaddy.com or some other website, then how do we manage it via AWS Route 53? Then creation of a public hosted zone in AWS Route 53. This public hosted zone is basically the place where we are going to create all the records, whether it is a record or a Cname record. And then we'll do a simple test, okay? So what we can do is, let me just first show you the actual application that is deployed. Okay, so this is the actual application deployed. Okay, it has two endpoints, the welcome flow. It's not going to do much. Okay, it's not a heavy application. It's just going to return back a status, a message, and an AWS region. Okay, so this is a kind of a AWS property by which we can CloudHub, basically on CloudHub, we can get the region where the application is running. Okay, and the second flow is basically a health flow. Okay, so the health flow is doing nothing much, just that it's returning back success and the instance is up and running. Okay, so we have this Mule Hello application, and if I go back to, let's see, yeah. So this is one of my account. If you see this, this is MM2, one of the account. Okay, and in this account, I have a VPC1, which is in US East Ohio. Okay, so this is basically the US East VPC, and inside it I have this application deployed and I have this load balancer. Okay, now let me just go inside this load balancer. Okay, what I've done is currently I've configured this load balancer to accept all traffic from a wildcard certificate, so star.wildcard.co.in. So this is a simple self-signed certificate that I've created, okay, and I've just uploaded it. I've ensured that it is a wildcard certificate so that we can use different subdomains for the different policy testing that we have to do. Okay, no other changes over here. All the default configuration, even if you go over here, right? The only thing that I've done is I've just applied US hyphen over here. That's it. So this is set up from the US side. Okay, the US region, something similar we'll have. So if I go to, so what I'm trying to do now is log in to my other account, platform account, where I basically set up a VPC and DLB in the Asia Pacific Singapore region. Okay, so let's quickly check that. Guys, if any point you are not able to see my screen, let me know, okay?
Yes.
Okay, so I've logged in over here. Let's go to the setup at this side also. So let's start with the VPC. Okay, the VPC is called as VPC2 as per the diagram. It is in Asia Pacific Singapore region. Okay, then we'll go to the load balancer. Okay, if you see the load balancer is SGDLP, and if I open it, it is sg-dlp.lp anypoint.dns.net. So this is the domain name of our load balancer. Okay, and then if you see the application which has the two endpoints that is deployed over here. Okay, so this is all set up that we have at the MuleSoft side. If everything is clear, we can go towards the AWS side now. Okay, so for AWS side, what we can do is, let me just go to the main dashboard. So what you need to do is log into your AWS console and go to, let's say, search over here, Route 53. Okay, so if you have not created anything, it will show a blank screen and create something that otherwise it will show over there. Otherwise, you can see all these things over there. Okay, so if I go back to the presentation, hold on. Okay, so the first thing that we need to check is for domain name registration, right? So for domain name registration, if you see in the Route 53 dashboard, there's something called as domain registration. Okay, if you click that, it will ask you for a page over here. So let's say if I want a domain name called as and this is .com. Okay, I can change it to .net or anything. And let's say if I want to check if .net is available, I can just click check over here. Okay, so what it says to me is that this is not available, but it is suggesting me some other options also. What I can do is, if I'm fine with these other options, I can just add it to the cart and buy it, or I can maybe change the names or change the extension and see if it is available. Okay, something like this. So for example, this is available, I can quickly go and buy it. Normally it's the price is for 1 year, but we can get it for 1 or 2 or 3 years also. That is up to us. So it's like simple steps, normal e-shopping kind of stuff. You have to go add to the cart, buy it, and then it will be activated within a couple of hours, and that domain will be yours for using. So this is the first functionality that is provided by AWS Route 53, which is domain name registration. Now the second thing is which I will quickly show is if you have not done this. So let's say if I have not registered my domain from this AWS Route 53, because there is no mandate, right? I can have the domain registered anywhere. So how does everything work if I don't have registered the domain name from Route 53? So what we can do is we can go to any other provider. So in this case, I have gone to Godaddy. So I have actually created a domain in Godaddy. And let me quickly log in. Give me 1 second. I just okay, it's there. Okay, so if you see there's a domain over here, this is the one that I'm going to use for this demo, vaibhav.co.in. Okay, so this domain is now basically created the same steps that I showed you for Route 53. I used it in GoDaddy and I created and bought a domain. So once I bought a domain, I get access to this domain. And what happens, and the most critical thing is, I'll show you quickly, the DNS management. What I'm trying to do is I'm not going to set up the DNS records over here. I'm just going to register the domain in GoDaddy, but set up all the records in Route 53. And the way we do it is we have to go to Route 53. Okay. If I go back to the main page, something called as a hosted zone. Okay. Go to the hosted zone. And I have to create a hosted zone. So click this button over here. And let's say I'm creating for vaibhav.co.uk. Okay, so whatever domain you want to create a records, mention it over here. Make sure that it is a public hosted zone, otherwise it will not be accessible from the internet. And that's pretty much it. Click the create hosted zone button. AWS Route 53 will instantly go and create this hosted zone for you. So by default, AWS Route 53 will create two records. If you see, one is an NS record, the name server record, and the SOA record. The next step that you have to do is, if you have to link your GoDaddy domain with AWS 53, then the thing you have to do is take the value for the name server record. So copy all these things, all the 4 values over here, go to your DNS management page, excuse me. So go to this management page at your Godaddy site or whichever site you're using, and update the custom name servers to those name servers. If you see over here, I've updated to the AWS name servers that I got from this page, this record. So all these 4 over here, I will go and update over here. Once this is done, what will happen is, although I registered a domain from godaddy.com, all the domain management will take place from Route 53, AWS Route 53. Okay, so once that is all set up, the only thing I have to go is create additional records. Cname Record, weighted routing policy, latency routing policy. So I can all create over here. And this will be my single point of source for all the DNS related activities. I don't need to go to my page or the place where I had registered my domain and all. So I can just remove this completely. Okay, I can have my entire focus over here. Okay, so I'll delete this one out because I already have one created. And I'll go to that domain. Okay, so if I go back, if you see this, this is the one that I, excuse me. Let's go back to hosted zone. This is the one that I've already created. Okay, vaibhavartka.co.in. This matches with the certificate that we have, the self-send certificate, which is a wildcard star.vaibhavartka.co.in. Okay, so let's go inside. And what we have is I've created a lot of records over here. Don't bother by the other records. We'll come to all of them records, all the records one by one. But if you see these 2 records, they are still there. And if you see this value, for example, for this NS record type, 534, 501, 18951, this is exactly what I must be having over here. 534, 501, 18951, So this is how I'm tying the registered domain with the hosted zone over here in AWS. Okay, so we should not delete this, and in fact, I don't think we can delete it also once it is created. And this is basically the admin kind of work, so don't touch this also. Apart from this, all these records are what we have created, as well as we'll create additional records now. Okay, so let's go to the next step. And okay, so all these things is done. So what we can do is, let's go for the first demo now. Okay. So what we're going to do is we're going to have a MuleSoft DLP vanity domain mapping. Okay. So we will have a new vanity domain mapped with the anypoint DLP. Test the connected to the API using the vanity domain. So the first thing that we'll do is, we know we have this, let me go back to the, this thing. So this is our USDLP, right? What I will do is, I will try to first access the DLP without using the vanity domain name. Okay, so this is the application that I'm going to hit. Okay, I'm going to hit this application. I can in fact open the logs if you want. Okay, so I have this open. What I'm going to hit, I'm going to hit this application just by the DLP name. Okay, so I have some endpoints over here. Yeah. So if you see this part, which is the DLP name, and then I have my application name and the welcome resource that we have. Okay, so I'll first test this if this is working fine, if we're getting a proper response. Perfect. Okay, and if you see, we're getting the region also US East 2. Okay, so this ensures that my DLP in the US East region is working perfectly fine. Now, as per the client requirement, I don't want this over here. Okay. I don't want this. What I want is, this is the TLB DNS and client requirement, for example, is to have it on, since this is US, let's say we take it as America dot, since assuming that the client's domain is vaibhavartka. Okay, so the clients want the host name to be something like this. Okay, so this is the requirement. Let's go by the requirement that what we have to do now is map America dot host name vaibhavartka. Sorry, this is scope, because that's our certificate, right? We have to map it to this. So let's do that. what we have to do is go to AWS Route 53. Okay, so here is where all the good things start, I would say. Go to create record. Select simple routing for now. Okay. There's a description also of all the routing policies that we have discussed also. So for example, simple routing is if you want all your clients to receive the same response and all. Okay, for weighted use when you have multiple resources that do the same job and you want to specify the proportion of traffic that goes to each resource. For example, 2 or more instances. So we'll come to this, but let's start with simple routing. I'll click next. Okay. So what it is asking me right now is add some records to this particular simple routing. So let me add a record. What subdomain do I want? So as we discussed, I want the subdomain as America. So let me just take America. Okay, so the URL will be america.webofadka.co.in. What's the record type? So it is not a record, right? Because I want to map it to a CNAME. I have to map it to a TLB. So I'll take a CNAME over here. Okay. If I want to map to directly an IP address, I would have selected A. But since I'm going to map to a DLB, I'm going to select CNAME. In fact, you can see a description also here. Choose when routing traffic to some elastic beanstalk environment or to Amazon RDS or databases. So anything, another domain. I think if you just read this first line, routes traffic to another domain name and to some AWS resources. So we'll select that. Okay. Value route traffic to choose endpoint. What we need to choose is IP address or another value. Another value, we have to provide the DLB hostname over here. So what is my DLB hostname? If I go back, this is my US setup, load balancer. I have to take this and enter it over here. Okay. The TTL is by default 300 seconds. I'll try to keep it as minimum as possible. So I just make it to 1 second. And let's define this. Okay, so I've defined this over here. I can define multiple records. For now, america.webofadka.co.in is all I want. Click create records. Okay, so if you see over here, there's a view status kind of thing. It is still pending. Let's give it a couple of seconds. Once this is done, what we can do is we can go and test it if our vanity domain stuff is working fine or not. Okay, let's refresh it and see. Any questions so far? Till we get this up and running?
No, clear.
Okay, so if you see our status now, it's in sync. So in sync is basically that the synchronization has been, yeah, sorry.
Did AWS Route 53 deprecate the allies record type?
Sorry, I didn't get you.
That's what the question from Sonu. Did AWS Route 53 deprecate the alias record name?
No, we can use alias, but we have not used it in this case. Normally it is used, let's say if you want to use forward to an internal AWS service and all, but here we are forwarding it to an external service, right? We are forwarding it to a MuleSoft DLB, which is external to the AWS world as such you can consider. Although the infra is AWS, but we are going to forward it to an external server, TLB in this case. So we haven't used alias over there. Okay. So this is my record, just to show it on the table. Okay, america.webofadka.co.in. CNAME, the routing policy is simple. And if you see, this is mapping to USDLB, LB, DNS. So I think it's a good time to test it. How do we test it? Excuse me. Take this name. Okay, I had another one over here, in fact. Yeah, so I'll do a duplicate of this. I'll close this. I'll close this. Okay. So what I have to do is let's put the domain name over here. Save this. And let's hope this works now. Perfect. Okay. So this is how simple it is. I mean, normally we go to the DNS admin and tell them that, okay, we have to map a particular record to the vanity domain name. But behind the scene, what they're doing is they're just entering one single record in the DNS system. And that is all that they do. And then it forwards it to our actual DLB. So what this has done is this request now is going to this actual DLB. getting the response. Okay. So that is the thing that I wanted to show over here with the vanity domain mapping. Let's move ahead. I think we are running out of time, right? Okay. So the next topic is a demo on the load distribution, failover and failure for MuleSoft APIs. So what we're going to cover is, in the interest of time, we're just going to cover weighted routing and geolocation. And then for the failure, obviously there's a failure routing that we'll consider. So let's start with the weighted routing. Okay, and for the weighted routing, let me go back to the AWS console. So, okay, so I can delete this. I don't want it now, so or I can keep it as it is, also no problem. What I will do is I'll filter based on the weighted policy. Okay, so if you see over here, I have created two records: weighted.vaibhav.co.in, the routing policy weighted, differentiator 30, pointing to Singapore. Okay, this is important. And then the same record, 70 US. Okay, if you want, what we can do is we can just go inside this and we can see all the values. TTL I've kept as 1, weight is 30. We can always go and update the records individually. But for now, what we say is we have this 2 records for testing our weighted functionality. Now, how do we test this? Basically, if we just take this the same way as we tested over here, right? So this is our Singapore one, correct? The Singapore one is returning this response that we saw, and this is our US one, USDLV, that is returning the US response. What we are going to do is we are going to have a new domain name, weighted.vaibhav.co.in, and when we accessed it, it has to go 30% time to this, 70% time to this. So now to test this and kind of replicate this, what I've done is I have actually create a batch file over here, weighted routing. Open this file. There's nothing fancy that I've done over here. I'm just pinging. I'm just doing a echo. Echo is just a kind of a text that will be printed, and then I'm pinging weighted.vaibhav.co.in. So this record, if you see, is exactly matching to what we have over here. So I'm doing a ping on weighted.vaibhav.co.in. Then I'm doing an echo, again a small line, and I'm repeating it for 10 times. If you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. So I'm doing this for 10 times. And then what I hope to see is that if the routing policy is properly configured and everything, then what we'll see is we'll see the response of all these pings just to understand which IP address it is connecting to. Okay, and we have the IP addresses over here in case we need the IP addresses. If you go to the DLB, right? So these are the 2 IP addresses for the US DLB, and similarly, if you go for this is the Singapore DLB. Let me just open it, keep it ready. So these are the 2 IP addresses for the Singapore DLB. Yeah, sorry.
Yeah, you could have used JMeter.
Sorry, I didn't get it.
No,
Yeah, I was planning to use JMeter. yeah. I was planning to use JMeter, but there was some kind of caching issue that I found with JMeter. It wasn't working, so I thought of this, and this worked for me last time. I hope.
Yeah, good one. It's good one.
Let's try this. So if everything is clear, what we can do now is we can go to this and try to hit this. So basically, we'll run our batch file, and it will access this records 10 times, and then we'll see if the split is happening properly or not. Okay. So what I have to just go into is weighted routing. Let me just run this file and let's see what happens. So I'll just maximize this a bit. So let this completely execute and then we'll have a count of how many requests went to which server and all, just to understand what is happening. Okay. Okay, so this is completed. If I scroll to the very top, Okay, so the first one went to, if you see this line over here, it went to the Singapore DLB. So one request went to Singapore. Sorry, let's close this. The first went to Singapore, the second went to Singapore again, third went to Singapore again, fourth went to US. So it's like 3-1. Then again to US 3-2. Then Singapore got the fourth one, so 4-2. Then US again 4-3. Then US again 4-4. Then US again 4-5. And US again 4-6. Okay, so this time it went around 6-4. I mean, we had configured it for 70-30, but this went roughly around 60-40. So it's not like exactly you'll get every time, because there might be other requests also accessing the server and all different things, right? But what Route 53 tries to do is do it as much as possible. It tries to execute the load. Maybe what we can do is we can try running again and see if we get some different output again. But you'll get fairly around to whatever you have set. So if you set to 80-20, you'll get something around at least 7 to 8 requests going to the 80% one, and then the rest going to the other one. We'll try it one more time, and then we'll move ahead. Okay, so this is completed. Let me just scroll up. So first went to US, one second to Singapore, so 1-1, then US 2-1, again US 3-1, again US 4-1, Singapore 4-2, Singapore 4-3, US 5-3, Singapore 5-4, US 6. So again, it went 6-4. So roughly around 60-40% of traffic is going, I guess. But that's fine. I mean, we have set it to 70-30, but it's going around 60-40 as of now. If we probably send more requests, we might get exact replica of what the setting is then. Okay, so this is the weighted one. Let's go on with the second one. Okay, the geolocation one. Okay, for geolocation, let's see what we have configured over here. If I just search for routing policy geolocation. Okay. Okay, so again, the record name is now geolocation dot. And guys, these records are working because I have set a wildcard character, okay, certificate. So whatever I put before the domain is going to be accepted by the TLB. Okay, I can play around with whatever the subdomain names are there. Okay, so for geolocation test, we have geolocation.voivopartco.co.in. Two records I've defined. Okay, geolocation I've mentioned Asia. Okay, so any request coming from Asia will go to the Singapore load balancer. Okay, any request coming from US basically is going to go to the US load balancer. Okay, so how do we test it again? I have again done something similar, I guess. Yeah, so there's a geolocation batch file. Okay, what I'm doing now is just sending again geolocation.voivopartco.co.in. I mean, I'm just sending it 10 times. I don't need to send to 10 times, but just to show how it works, I'm just sending it 10 times. So exactly the same script as weighted routing. The only difference is now I'm sending it to geolocation.voivopartco.co.in rather than in weighted, I was sending it to weighted. That is the only difference. The subdomain has changed. Now, the thing over here is that if I execute this script from my system, okay, so this is the interesting part. If I go over here and yeah. So if I go and check what is my IP address, okay, my public IP, it is showing that I am from Mumbai, Maharashtra. Okay, so I'm in India, basically in Asia, right? So as per this policy that we have, when I access this, irrespective of whether I access it 1 time, 2 time, or 10 times, it should always go to the Singapore load balancer. That is what we have configured. So let's try and see what is happening. Let me close this. Let me go back to our batch file and I'll execute this and we'll see what happens. Okay, so this is going to go now 10 times. So this is done. Let's scroll up just to verify what our understanding is correct. So if you see this, the first ping, it went to HTTLP, Singapore TLP, again to Singapore. And if you see again, it's going all to Singapore. And the reason it's going from Singapore, going to the Singapore TLP is because I am calling it from Mumbai region, which is in Asia. And I have set this. So even though I have two records, it never goes for this record because the caller or the user is calling from Asia. So it is always going to this. Okay, so what we can quickly do is also test if the other record is working. Okay, so what we'll do is we'll try to connect to a VPN and basically assume that we are in US, and then we'll run the same batch. Okay, so this is verified. Everything is going to SG. Okay, so if I just see the other request also, all 10 have gone to SG. So I'll close this, and what I'll quickly do is let me just there's some problem, I guess. So what I'm trying to do is just connect to a VPN, and if it hopefully connects, then we can test the other record and see how it works. Give me 1 second.
Do you have any EC2 instance in your AWS account?
Actually, no, I don't. I was planning to have it, but I couldn't. If we have, if anyone has it, then we can just do a curl command. I can give you the URL, and we can see what output we're getting over there.
Anybody's from US? Anybody from other region? So what happens to the other regions if it is not from Asia or the US? What will happen? Where
So
will it
they
go?
will fail. As per my understanding, that will fail. Okay, but if we put a default record, okay, so let me, I think my screen sharing has stopped, right? 1 second.
Yeah.
Can you see my screen?
Yes.
Okay, so if you come back to this records over here, let's say if I add another record, okay, so I'm in this particular policy, I'm creating a record. Okay, I'm going for geolocation. Let me do next. Okay, I'm doing the same domain name geolocation.is. Everything will be the same. This will be Cname, for example. I can know this. And here, when we define the records, basically, there's something called as a default record. Let me see if I can find it somewhere. I'll just take an example value over here. Yeah, this is the value. Okay, so let's say this is some DLB. Just an example I'm just showing for this record. What I'm saying is that this will be the default record. Okay, I can just mention it default. And I can point it to any DLB or any system, but I'm just showing a sample thing over here. Default record, create records. Okay, so what this does is, if I just filter by the routing policy, geolocation. So now I have 3 now. Okay, any request coming from Asia will basically go to the Singapore load balancer. Okay, any request coming from the United States will go to the US load balancer. And if any user calls from any of the regions outside these two, then this record will get invoked and it will go to this load balancer, whatever we define over here. So we can have the same load balancer also defined. Let's say this is a default one, then we can have it defined over here and it will be redirected over there. Without this record, I guess there'll be an error. You'll not get back a response. I haven't tested it though, but I guess you'll not get anything if the user is from outside Asia or outside United States. Then. Not sure why this is not connecting. Does anyone have any EC2 instance, or is anyone connected from? Does anyone have any public IP which is in the US? Probably we can just check quickly.
Francis, are you still there? Can you help us?
I am, but I'm logged on with an iPad at the moment. I'm not on my computer, I'm afraid.
Okay. Yeah, no problem, but we got the idea. Vaibhav.
Yeah, I think we can. I mean, if you get anyone access, you can just try to access this. Once you get to let's say a machine in the US which has a public IP in the US, try to access this record. I'll keep this up for maybe a day or something. And if you access it from that particular location, then you'll be able to see all the requests going to the US load balancer.
Yep.
Okay, moving ahead. I think, yeah, the last one that we have to cover is the failure one, which is pretty straightforward, but we'll still go into it. All right, so let's select the failure one, what we have. Okay, so here, if you see, we have failover defined records, failover.co.in, and again the same record. Now, the differentiator over here is primary and secondary. What I've designated is that when I get a request for failover.co.in, my primary resource or the primary API that is going to serve is this one. Only if and only if this goes down, then the request has to go to this one. Okay, so what we can probably do right now first is try to access this. Okay, so let's take this and let's do a quick ping to see what we're getting right now. Okay, so if you see this, it is going to the USDLP. Okay, that means that the USDLP, that particular server is working fine, hence we're getting a response from the USDLP. Okay, even if I do it again, it will go to the USDLP itself because that is running fine. Now, before we go to the failure, actual failure, we need to understand what is happening over here, because this record, the primary record, has a health check associated with it. And to understand what the health check is, let's go to health checks on the left-hand side over here. If you see, I have defined a health check over here. This is quite simple. I can just create health check over here. What I need to give is my name that you want to give. What you want to monitor, I can just give it as endpoint. If you want to send the health check request to an IP address, you can click IP address. But in my case, I want to send it to a domain name, so I click over here. I can select whether it is HTTP, HTTPS, the domain name. So in my case, basically, if you remember the diagram that we had, we have some health check endpoints in this API, the application that we deployed, right? We had a health check endpoint over here in this particular app. So just like we were accessing /welcome over here, I think there was what it called health. Let me check. Yeah. So this is the endpoint. So what we're trying to do as a part of AWS Route 53 health check endpoints is make sure that Route 53 calls this particular endpoint. Okay. If it calls this endpoints regularly at regular intervals, it is going to get back this response with a 200 OK. And since it is a 200 OK, it will understand that this particular server is up and running and it can process requests. Okay, so that is what we do over here in this particular health check. We provide the domain name, the port, the path. So in the path, basically, we provide this entire path till health. So in fact, what I can show you is what I have configured rather than creating a new one. So this is the one that is configured. So if you see over here, can anyone see my screen? This is a uniquely generated ID, so ignore that for now. This is the most important thing, the URL. So the health check service of AWS Route 53 is going to regularly ping, or you can say send a request to this thing. This is what I've configured, and if you see, this is the health endpoint of my USDLP. Okay, the protocol is HTTPS, domain name is this, port. So all basic things that are just basically used for pointing to this address. It's the same address that you see over here. And some advanced configurations such as request intervals. So it's like after every 30 seconds. Now it's not health check thread is going to send after every 30 seconds. They have n number of threads across the world for health checks, and each of them, once they get a response, they'll send back the next request after 30 seconds. The failure threshold is basically, let's say if they get consecutive 3 failures from these endpoints, then the health check, this particular health check, will conclude that the endpoint or the server is down. So let's say if we just get 1 failure, if I call this and if I don't get a 200 OK, Okay, that doesn't mean that this server is down as per this configuration. Only if I get 3 consecutive failures, then this health check will fail. So this is the configuration we can obviously change. We can basically have it fine-tuned as per to our requirement what we wanted. These are just the graphs. So I'll come to the graphs later. These are the health checkers. So this is out of the box provided by AWS Route 53. So you can see different regions, and these are the health checker IPs. So essentially, they are the requests. They are going from this IPs basically across the regions, and they are basically getting. This is what the API is returning. So it is returning 200. Okay. So currently, since the health check is successful, everything is success over here. But what you'll see is when that server is down, this will start to fail. Okay, so once you start seeing this to be failing, this will start turning red. Okay, and the health check basically will say that okay, the primary endpoint is it's not healthy in short. In that case, what will happen is if I go back to the records, okay, so I just go back over here and I will select failover. Okay, this basically will then fail and it will go to this. Now the missing link is how have I linked this particular record with the health check. So for that, let me just click this edit record. So information, the basic information such as where it has to point to, the TTLs, and then the important thing is that the routing policy is selected, and then the most important thing is the failover record type. So in failover record type, you can see there's two things, primary and secondary. So what I've done is I have this particular record as a primary failover record. And then if you see, this is the health check ID associated with it. If I click this over here, you can see primary health check. This is the name of our health check. Selected this. And then this is just a name that I've given. Now, if I open the same for the other record, it will be slightly different. Okay, so this is the other record. If you see now, it is pointing to the Singapore DLB. That's the first difference. The second thing is the failover record type is not primary now, it is secondary. And this is just a label that I'm saying that this is a secondary record and it is present in Singapore. Okay. And it's quite simple to do it. So if you just create a record, select failover over here, it mentions used to route traffic to a resource when the resource is healthy or a different resource when the first resource is unhealthy. Okay, click next. Enter whatever your domain name is. In my case, I had failover, right? Again, the record type, the TTL, and then in define failover record, this is where you have to select whether the record type is primary or secondary. So this is primary, and the other one you can have it as secondary. Okay, and then obviously the health check. So health check is mandatory only for the primary endpoint. You can have it for the both endpoints, even for the secondary one, but it is not mandatory for the secondary record. Okay, so if we go back, routing policy failover. Okay, so we have this ready now. What we are going to do now is to test this. We have tested the normal scenario, right? It is going to USDLB. Correct?
Well, one more question.
Yeah.
So how many secondary record we can have here?
To be honest, I've not tried it. I've just tried it one primary and one secondary. I'm not sure if we put another one, we might have to link it to a set of policies or something to understand.
Yeah, because I was thinking, like, let's say the primary record, primary DLP is down. How this guy is deciding which one should become primary now? Rest of the if you have single record, it's very simple.
Yes.
But if there are multiples, then which one will
Correct.
become primary?
No, I get your point. But to be honest, I've not tested it. When we have multiple secondary records, how it is deciding whether it's using any internal algorithm, round robin, or what exactly. I'm not too sure of that. We need to check that. I might get back to you on that one then. Okay, so the way we test it is quite simple. Since the primary is US1, let's go over here. This is a US, I guess. This is a US one. Yeah, this is the US one. What I'll do is I'll just bring down the application. Okay, so let's wait for this application to go down. And the thing to note over here is that even when this goes down, right, immediately the failure will not work because we have configured certain things, right? If you saw that health check thing.
3 times.
Yeah. Yeah, so behind the scenes, it will calculate whether it right now it is healthy if you see, because everything is, we'll just monitor, I think, the health checkers over here so that we know when it has started failing. So as of now, if you see, everything is success. All the health check threads or all the health check services that they have across the globe, they are getting success message. Where are we? Okay, so this is undeployed. So now we have to just keep on monitoring this for some time, okay, to see when this starts failing. Okay, take probably maybe a few seconds before we start seeing some failure messages over here. And then what we can do is, once we start seeing some failure messages, then we'll go back again to the command prompt. And what we'll do is we'll go for the same record type, failover dot webhub.co.in, and we'll see that if it is now going to the other secondary resource, which was like the Singapore one, right, where it has to go on failover. So that automatic failure, whether it is working or not, we can check. So probably we'll need to give it some time. Okay, so if you see now it has started failing, the endpoint did not get. So this particular one sent request, it got some failure. This one also got some failure. Okay, so what we can also do at the same time is there's a monitoring section over here. Okay, so if you see right now, in the past intervals, everything was 100% successful. But now since it has started failing, it will start going down somewhere over here. And at the same time, because we know this will now happen at any time, let me open a command prompt again. So, and I just get, I think it was failover, right? Failover. So let's see where we are. Still, there's nothing shown as failure over here. Even the health check endpoint is still healthy. Okay, so if we send now, I think it will still go to the US one. No, it has redirected. So if you see, it has now gone to SG1, Singapore one. So this might take maybe some time to reflect, but now we should be able to see something. Let's go back. Yeah, so quite a few have started failing now. You see, there's a lot of them failing. We should be able to, yeah, if you see now over here, it has started going down. 80% of the requests have failed and all. And if we keep on sending it, yeah, this one also has gone to Singapore. Irrespective of n number of times we keep on doing it, we'll keep on sending it to Singapore DLP itself, because now it is the failure one. So okay, go back to the records again. Okay, so this is the failure one. So that's the reason it is going to this particular one. And this is matching with what we have over here. Okay. Now, how do we test again that once we bring this up, the failure is implemented? We can just start this. Okay, so let this start. After this starts, again, all these endpoints that we had, right, the health check endpoints, they will start again being successful, all of them. Okay, so right now, if you see, almost all of them are failing now. Once our app is up, all of them will now start being successful again. And then if we just hit the same endpoint again, it will go back to the USDLP. Okay, so let's give it some time for this to run up. And meanwhile, I think, one second, probably that's the end of the session. Yeah, so there's just one more thing I'll show before I end this session, if that's okay, which is the geoproximity thing, that's quite interesting. So for geoproximity, I mean, we'll just come back to this, but for geoproximity, if you see, we don't have a policy over here in Route 53. Let me just show you quickly. So if I go back over here, and if I go for create record, if you see, there's just simple routing, weighted, geolocation, latency, failure, multi-value answer. We haven't covered this IP base. It's, I mean, not widely used, I would say. But there's no geoproximity thing over here. And the reason is because there's a different way of setting it. We need to go to something called as traffic policies over here. And in traffic policy, I mean, this is just for information. I'll not give a demo on that because I don't have anything configured. So if I have geoproximity policy, I can have some description, click next. Okay, Okay, so what it's doing is it's giving a visual representation of how the traffic should flow. So what I can say is I want a Cname mapping over here, which then connects to a Geoproximity rule. So when I say a Geoproximity rule, okay, I can enter an endpoint over here. So let's say if mine is in US East Ohio, okay, I can mention that it has to connect to a new endpoint. And let me give some name, US DLP. So this will be the actual host name of the DLP. Okay, I'm just giving a sample over here. And then if you see there's region 2 also, what I can select is the one that we have, that is Asia Pacific, Singapore, and a new endpoint, which will be the endpoint for, let's say, SGDLP. So the entire domain name for the Singapore load balancer. So once we have this, and if you see the bias value is 0, a quick way to check what traffic will be routed is clicking this button. So if you click this, it will show you the entire map of which request will flow to which regions. Okay, so this is what we have. This is exactly that I put in the slide. So for one, which is US East, all this traffic will go to the first server that I have defined. And for region 2, which is this one, all the traffic in this range will go over here. Okay, and if I play around with this value, so let's say if I do for one as 40, immediately you can see this to be changing then. Yeah, so if you see this now, since it is 40, the range has changed now. It has 40% more. One has 40% more. If I let's say increase it to 70, it will have even more. Yeah, so if you see now it has increased. So all the users calling from this blue region now are going to go to 1. Everything from red is going to go to 2. If I make it back to 0, it will be again equal 50-50 distribution. So, I mean, this we have to set accordingly and then we can get it. The reason I didn't do it because this is quite expensive. I think the daily cost for having this set is a bit high. So I didn't go for it. But in short, we can have some kind of functionality, the geo-proximity kind of functionality based on this traffic rule thing. Okay, so we'll just go and confirm if the server is up. We'll check if our health check is fine. Let's see what the health checks. Going green. Okay, so this is the health check. Let's see the health checkers. Okay, so most of them are now returning success if you see. Okay, and even in monitoring, it should start reflecting. So if you see, it went down over here at this stage, but gradually, yeah, it has started picking up now. So if I do same thing, so previously if you see it was going to SG, right? So if I just do again, yeah, you see now it has gone to USDL. And even if I do it multiple times now, it will go to USDLP until and unless again the health check finds that the USDLP is down, then it will go back to SG. So I guess that's pretty much it. I'm sorry guys, I could not show the geolocation thing for US, but I think the rest all I have covered. Any questions anyone has to so far based on what I have covered or anything in general?
No, Vaibhav, we are good.
All right. Thank you guys then. Thank you.
Okay.
Do you want to share your screen? Should I stop sharing?
Yeah, I'll take it from here. So thank you so much, Vaibhav, for this awesome session, man. Okay, I really enjoyed it. Okay, and if there are no questions, we'll move on to the next part, which is our trivia
Ashish, I
quiz.
can share the screen.
Okay, I'll share my screen. So
Yeah, thank you very much, Vaibhav. As Ashish mentioned, I think it's very interesting and we really enjoyed.
Hey,
It's
thank you.
almost 2 hours, right?
yeah, yeah,
Yeah,
But
slightly
the thing
lengthy.
is that,
I know.
yeah, good thing is most of the people they can't directly go to the AWS and see, right? So
correct.
we have shown all that. Yeah,
Yeah,
thank you very much, Vaibhav.
Yeah,
thank you.
Vaibhav, you stop sharing. Okay, then only I'll give you.
Ashish, I can
I
share
have.
this.
Yeah.
I can.
Okay, no problem. Go ahead.
Okay. Yeah, we'll start the quiz. So I request all of you to log in into Kahoot.in and please use this pin to access the Kahoot. So for
Yes, you need to use your mobile, guys. So from your mobile, use scout.it, right? And then this is the pin, okay? And give
In my
your,
screen, you will be seeing the questions, and in your screen, you can see only the color to choose. So that's how it
yeah,
will work.
color with your shapes.
Yes.
Okay,
And
and give your proper name.
proper name. Yeah.
And one more request to everyone, if you have owned the voucher in the last 1 month, or if you are a speaker or if you are organizers, so give the chance to other people. Okay, so I'm looking at right now, so the count is 34. 30% is at least 25 I'm expecting. Okay, Rina, no problem. 2 minutes. Okay. Let us know if you have any issues, guys. Okay, we'll wait for 5 minutes. No issues.
So anyone facing any issue, please let us know. We can help you.
Rina, you're okay now? Yeah, please let us know. Okay, so you asked for 2 minutes. Kotlanka, how about you? Rina,
Like,
Kotlanka. You guys let us know, please. Okay, so I'll stop the recording.
It's I'm just
Okay, no problem.